So on the quiz, let's compare. Got a load of those little English set test questions. Compare and contrast. Now, if you compare, aren't you contrasting? If you contrast, you compare. Number 4 is like number 1 over here, except number 1, instead of just a simple integer, and you got to simplify the radical, then you combine my terms, you have radicals, you have all the radicals. You combine like that. So you have to simplify. You got to do a lot of it when you simplify. And then the second one, the multiplication, a lot like number 5 right there. But as you can tell, 2 square root of 25, that's a nice perfect square, 2 times 5, minus the square root of negative 36. Oh, 36, that's a nice perfect square. 5 times square root of 49, oh, that's a nice perfect square. Plus square root of negative, that's a nice perfect square. Versus this example, not a perfect square, not a perfect square, not a perfect square. You're gonna have radicals left over. Your test is somewhere in between. So this is definitely more ugly than your test. But the quiz was not as difficult as your test. Which means, hello, review sheet. Okay. And I think the review sheet's even tougher than your test. I don't know, let me keep your test. Let me take a sneak peek. The multiplication's a little bit more, it's a little prettier. But this is about the level of your test question for adding and subtracting. So here we go. You got to simplify. Take your time. But here's what I'm talking about when I say take your time. It's called, this is what the phrase we would use in basketball. You got to be quick, but don't hurry. Be quick, but don't hurry. That means you should know what you're doing before you get in here. That's why we practice. Over and over and over and over. So when you're not running that game, you're playing that game, you're not scattered all over the place trying to figure out what you're doing. And you can be quick about it and not frantic about it, not panicked about it. Open note quiz, it was looking through all the papers, trying to figure out what am I doing next, instead of focusing on, let me just do the problem. And when when I'm stuck, then I will adjust looking through the notes. But are my notes organized? I don't care if you have the right answer. If your work is not there, you're not going to get much credit. When you see your quiz, first of all, remember there was a miscalculation when I did my cut and pasting. At the top it said 6 points each. They're actually 8 points each. And the bonuses I bumped up to 5 points each instead of 3. So that's why there's discrepancy on what it says at the top and how many points it came off. But it all balanced out, especially when you buffed up the bonus questions. But I saw there was a handful where the problem was here, and there's the answer. Nothing was out of 8 points, they got 2. Where's the answer coming from? They know how to use calculator. Then I guess I'll call Texas Instruments and tell them they got an A on the quiz. You gotta show me the work. This isn't a calculator class, it's an algebra class. So you gotta show me you can do the algebra. There we go. First thing, bring down the getaway car. That is 6. And then simplify the square root of 45. You pick a couple of numbers, how about 9 times 5? You got a 3 times a 3 and a 5. So 6 times, do that. 6 times 3 will escape. And a 5 goes back in square root jail. So this is 6 times, this is 3 square root 5. And then you have the plus 4. That's the getaway car times. First thing you want to do is square root of a negative, you're going to poke out the other. And then 90. Now we can go with 9 times 10. And that's a 3 times a 3 and a 2 times a 5. So a 3 will escape. There's nothing you can break out with a 2 and a 5. That's as far as it goes. So these two go back in square root jail. And when you put them back in square root jail, it goes back as a square root 10. You both put them back together. So it's this one. And then again, working from left to right. This is what I have so far. I'll come back to you in a minute. And then you got to remember, you're going to subtract the next one. Subtract and then parentheses. 10 is a getaway car. Now here is the hint. You just simplified this one. It has a square root 5. That's the hint as to what you should probably use over there to break that square root 80 apart. If I'm going to combine like terms, because we're subtracting here, if I'm going to combine like terms, then this one, which doesn't have an I, and that one's not going to have an I because it's not negative, then the only thing I can combine are square root 5 terms. Something square root 5 and something square root 5. So this one hopefully will have a square root 5 left over. So just think about this is 16 times 5. You have a calculator, 80 divided by 5 is 16. And that will help you figure out what that one's going to be. Because you know what this one has. It's a clue, it's a hint. So 16 is 4 times 4. And you have a 5 left in square jail. So 4 will break out. A 4 is going to bust out. And 5 goes back in square jail. And then the next one, minus 5 times. Getaway car minus 5. And then times. It's the square root of a negative, so poke the I out. 160. Now, when you look over here, if I'm going to combine this term, which is an I square root 10, then the only thing I can combine this term, I square root 10, is with another I square root 10. There's the I. So let's just go with 160 is 16 times a 10. Again, there's the hint. I'm going to want a square root 10 left over inside the square root. 16 is 4 times 4, and then you have that 2 times 5 again. 4 will break out, so 4i. 2 and 5 can't break out, so they go back in as a square root 10. So the work I did in this parentheses, coming up with a square root 5 in this term, gives me a clue to what I should end up with over here. Coming up with an I square root 10 over here gives me a hint with what I should end up with from this factor. And this is for the addition subtraction problem. So now the next one. 6 times 3 square root 5 is 18 square root 5. 5. And then plus 4 times 3i square root 10 is plus 12i square root 10. So the parentheses is done. So I don't need the parentheses anymore. But you got to be careful there. Remember, it's minus that. I'm not done in there yet, so I'm not ready to subtract yet. 10 times 4 square root 5 is 40 square root 5. Minus 5 times 4i square root 10 is minus 20i square root 10. And what happens when you subtract a whole parenthesis? When I subtract this parenthesis, what's going to happen? The signs are going to change. Now, if you do it here, it's not bad. As long as you remember this, that's a positive, so now it's going to be a negative. That's a negative, so you got to make sure it's a positive. Okay? But if you don't bring the parentheses down, you just skip that step, you're not going to distribute without the parentheses. So until you distribute, you need the parentheses. So this is minus 40 square root 5, minus a negative, that's plus 29 square root 5. So now we can combine like terms. So 18 square root 5 and a negative 40 square root 5. So 18 of those square root 5, take away 40 of those square root 5s is negative 22 of those square root 5s.
Would that be a 10? Or is it the 5 scale, the 20 items?
Yes, it's supposed to be a 10. And then you get your 12 I square root 10s, and then you get 20 I square root 10s. So these are like terms. So 12 of these plus 20 more of them is 32 of those I square root 10. And you can't go any further because they're not like terms. What did I say about where the I should go when you have a square root?
Over here, not over here too.
Yeah, so between the number and the radical. And I'm getting this from a few people. And I was seeing this. So it looks like I is inside the square root, which means that that's wrong. And you know why? Because that's what the calculator will write. They'll put the I after the square root. I'm telling you, put it here, so there is no question that it's not in the square root, it's times the square root. That way we're sure. That's how I can tell that there's a little machine there. Now, if you check it with your calculator, I don't have a problem with that. That's what tools are for. Okay. And then the next one, we're multiplying. Remember, just because you see parentheses doesn't mean you're multiplying. There's minus in between. We're adding or subtracting. You have a question like this, then you have to do a multiplication. Step one, simplify first, order of operations. What's inside the parentheses? And I apologize, I was watching, or I was looking at the picture I took of my work from yesterday, and I'm looking at my handwriting, how bad it's gotten. And it feels like these pins are like 3 pounds. And I don't know if 3 pounds is in a lot, but with my shoulder, it's like I can't write straight in parts. It's depressing. So here we go. Give me two numbers that make 32. 8 times 4. Now we got to remember that 8 is 2 times 2 times 2, and then 4 is another 2 times 2. Technically, 32 is 2 to the 5th. So let's see who's breaking out. There's a 2 that breaks out. There's another 2 that breaks out, and you got a 2 left behind. So square root 32 is 4 square root 2. Okay. And then you have a plus. Poke out the I. Give me a couple of numbers that make the 12. 2 and 6. And then you got a 2, and you got a 2, and you got a 3. So a 2 will break out, and you have a 3 back in square root. So that's the first parentheses. Times. This one has a getaway car, green. Give me a couple of numbers that make 50. 5 and 10. And then you have a 5, and 10 is 5 times 2. So 3 times 5 escapes, and a 2 left in square root jail, 5 square root 2. And then we have minus, the getaway part here is a 4, minus 4 times, poke out the I because it's a negative. You need to know forever that 27 is 3 times 3 times 3. It's perfect cube. Okay, 8 is a perfect cube, it's 2 to the third. 27 is a perfect cube, it's 3 to the third. 27. 9 times 3. 9 is 3 times 3 again times 3. There's numbers that you're going to do all the time. 8 is 2 to the third, 27 is 3 to the third. 64 is 4 to the third. Okay. So here, 3 escapes, and you have a square root 3 left in J. We're not ready to multiply yet. This one's good to go, but this one's not done simplifying. So it's this 4 square root 2 plus 2i square root 3. And then this one is 3 times 5 times 4. That's 15 square root 2 minus 12i square root 2. If you know what you're doing, you don't have to do this next step. And if you're cautious, then you should do this next step. Because now it's just distribution. It's foiling. So here's what it looks like. You're going to distribute 4 square root 2 to each one. So make sure you do your sign. This is a positive times a positive. It's going to be 4 square root 2 times that 15 square root 2. And I'm not going to do that yet, I'm just writing them out. Then we have a positive times a negative. So a positive times a negative is going to be a negative. And it's a 4 square root 2 times a 12i squared 3. So we're done with the 4 square root 2. Now we're going to distribute 2i squared 3. So positive times a positive, this is a positive. 2i squared 3 times 15 square root 2. And when you do last times last with complex numbers, this is where it gets a little tricky. A positive times a negative is going to be a negative. Positive times a negative. And you're going to have 2i squared 3 times 12i squared 3. Okay. Using the property of multiplication. This is, again, you don't have to show this step. I'll show you where you can actually go to without doing the supplementation. This is 4 times the square root of 2 times a 15 times another square root of 2. The commutative property says A times B is the same as B times A. You can change the order. So I can switch the square root of 2 and the 15 and rewrite it as 4 times 15 times this square root of 2 times that square root of 2. 4 times 15 is 60. And then this, the nth root of A times the nth root of B, as long as they're the same kind of radical, is just the nth root, one radical, and you multiply what's inside. Also, if you have a square root of A and you square it, a square undoes the square root and you just get A. Or if you have the square root of an A squared, the square root of a perfect square is just A. A square root undoes the square. So square root of 2 times square root of 2. You can look at that as square root 2 times 2 is a 4. And the square root of 4 is 2. Or you can look at it as square root 2 times square root 2 is square root 2 squared. And the square root of 2 times itself squared is just a 2. Okay. So no matter what, when I multiply this square root 2 times itself, you're going to square that square root because it's the same number, and you're just going to get that 2. So here's what I'm saying is, when you do this, 4 square root 2 times 15 square root 2, 4 times 15 is 60. Square root 2 times square root 2 is 2. You could go from here to the 60 times 2. You wouldn't have to show anything in between. But how do I get to 60 times 2? Everything in between. So if you're not sure about what you're doing, the steps in between. Then we have minus. So doing what I just did, 4 times the 12, so that's going to be minus 4 times the 12. And you have a square root 2. We have the I, looking at the I. So 4 times the 12 times the I, and the square roots go last. Square root 2 times that square root 3. So minus 48. And I, now these are not the same number. We're not squaring a square root. It's square root 6. And it's this. Nth root of A, nth root of B, you multiply what's inside. That's the square root of a 2 times a 3. It's a 6. That's not a perfect square. And you can go from that without showing it. 4 square root 2 times negative 12i, square root 3. 4 times negative 12, we have negative 48. We have an I. Square root 2 times square root 3, we have a square root 6. But again, if you're not sure, show the step in between. We have this plus. We have a 2 times the 15. Don't forget there's an I, and you have a square root 3 and another square root 2. So we have a plus 2 times 15 is a 30. And I, square root 3 times square root 2 is a square root 6. So that's a plus 30 I square root of 6. And then last times last, again, here comes the careful stuff. First off, it's minus. And we're going to have 2 times a 12. We have an I times an I. I times an I. And we have square root 3 times square root 3. If I just stretch it all out. So that's a minus. 2 times 12 is 24. I times I is I to the second. Square root 3 times square root 3 is square root 3 squared, which is what? It's just a 3. Or it's square root of 9, which is just what? A 3. So any way you look at it, it's just a 3, because it's a square root times itself. So that's a minus 24. What is I squared? Times a negative 1 times a 3. Negative 24 times negative 1 is positive 24. 24 times 3 is equal to 72. You gotta be really careful if you do last times last. And you can go from here to here, but actually you should probably go to here. 2 times positive times negative, negative 24. 2 times 12, 24. And then I times I is your I squared. Square root 3 times square root 3 is your 3. Okay? Negative, that's a negative. Then we have 3. Multiply it all out, plus 72. Like terms. What's 6 times 2? 60 times 2. So that's our 120. 120 and a 72 is 192. So these add up to 192. And then you have negative 48 of these I squared sixes. And then plus 30 of these I squared sixes. So negative 48 of them. And plus 30 is negative 18 of those I square root 60. Now remember where this started. It started and it wasn't simplified to begin with. So there was a lot of steps in between. It's not going to be this tough. You will have to do a little simplifying, but maybe I'll be a little nicer, and maybe one of these radicals is a nice perfect square, so it's not as much simplified. But you have to simplify first. Now, figure out what you want to see on the review sheet. I'm just going to double check roll Becca or Brianna. Nope. Kimberly? Javier? Myra? Wanda? Vanessa? Dakota? Here. See you. And Jen. Okay, from the review or whatever you want to do. Here's your point. At 10 o'clock, I'll tell you how it matches up to the test. Three. So 9 minus 15i squared. So if you know your special product, your a minus b squared. If you know how to go with your a minus b whole thing squared, you square the first one, a squared, in the middle, minus 2 times ab, and then you have a plus b squared. So the first one squared would be 9 squared, minus 2 times these two multiply together, times a 9, times a 15i, and then a plus the parentheses 15i whole thing squared. 9 squared. So that's 81. Now, I'm looking at this, I'm going to go 2 times 15 is 30. 30 times 9 is 270. So minus 270i. And this is 15 squared is 225 times I to the second. So this equals 81 minus 270 times I. And then what's I squared? -1, so that's 225 times -1, so minus 225. These are your two like terms. Obviously, 225 minus 81, we get 4, that's going to be 144. So negative 144 minus 270. If you use a special product. If you don't want to, then you got to do this. 9 minus 15i times 9 minus 15i. And distribute. 9 times 9, that's an 81. A positive times a negative, that's a negative. 9 times 15 is 135 times I. And then inside times inside, negative times a positive, that's a negative. 15i times 9, another 135 I. And then last times last, negative times a negative, positive. 15i times 15i is 225 I squared. So there's our 81, negative 135i minus 135i is negative 270i. And again, this is 225 times negative 1, so it's minus 225. These are two real numbers. 81 minus 225 is negative 144. And that's an imaginary minus 270. So whether you multiply it out, FOIL it, or know your special product, as long as the work is there, everything's happy, joy. But when you show up on Thursday, have that plan. Know how you're going to do that problem. Remember, no notes. Pencil, calculator, in your brain. What else? What else? 6. So the directions on 6, you have to solve by factor. Have to. Three x to the third equals negative 48x. The first step with factoring, it has to be equal to 0. Has to be. So I'm going to add 48x to both sides. And you bring this over to the left. So plus 48x plus 48x. And the first clue that something's up, 3x to the third plus 48x equals 0. The first clue that something's up is x to the third. We're solving quadratics. We're supposed to be solving ax squared plus bx plus c equals 0. And that's an x to the third, so something's up. Solve by factoring. So the first step of factoring is take out the greatest common factor. So when you do the greatest common factor, first thing you look at is the coefficients, the 3 and the 48. The only thing you can take out of this first term is a 3. Can I factor a 3 out of the 48? In other words, does 3 go into a 48? Is it divisible by 3? Yes. So I can factor a 3 out of each term. And then look at the variable, x to the third and an x to the first. Do they have an x in common? Well, they each have some x's. What's the most x's that they each have in common? Just one. Well, friend, there's only one x this will pick you up. This has 3 of them, but this only has 1. So the most x's that I can take out of both terms is just a single x. So the greatest common factor is a 3 times x, 3x. That's what I'm going to factor out. And remember, factoring out the greatest common factor is reversing distribution. Distribution you multiply in. When you factor out, you're dividing the 3x out. 3x to the third divided by 3x. The 3's reduce. X goes into x to the third, leaving x squared. Plus 3 goes into 48 16 times. The x is reduced. This is just plus 16 equals 0. You factored it. Now, if you try to factor x squared plus 16, that's prime. It's the sum of two perfect squares. It's not factoring anymore. But the whole point of factoring is once you have it factored completely, and that's done, you can't factor it anymore. you let each factor equal 0. So we're solving for x. This has an x. So you let that 3x equal 0. And you let this x squared plus 16, so let that factor equal 0. We divide by 3. What is 0 divided by 3? 0. And if you check it, what's 0 to the third?
0.
Thank you. 3 times 0? And negative 48 times 0. You get 0 equals 0. So 0 is 0. And then this one is just the square root. Square root method. Perfect square and a number. So we isolate the perfect square. And we get x squared equals negative 16. Take the square root of both sides. Don't forget your plus and minus. X is equal to plus or minus. Square root of the negative, you're going to poke out the I. The square root of 16 is 4. So our three answers, we have a 0, comma, and we have a plus or minus of 4.
I'm pretty checking this covered, so I'm gonna go back to the train.
This is basically 2.4, 2.5. That's done. Seven is also under the rules of solve by factor. Any other method gets 0 points. 7 is 16x squared equals 24x plus 112. I'm very deliberate about that choice. Why I gave that particular question. In order to solve by factor, in order to solve with a quadratic formula, it has to be equal to 0. You want to keep your square term positive. I know it's simpler and only one thing you got to do is move 16x squared to the right, subtract 16x squared from both sides. But then you have negative 16x squared. So when you factor it, you got to make a negative 16x squared as your first term. And what happens is people forget about making the negative part. Or they move the 16x squared to the right side, but they forget that there's a negative there. They just don't write it. It has to be equal to 0. Keep the square term positive. I put this up here for a reason. So if I'm going to keep that square term positive, that means I'm going to bring the 24x and the 112 to the left. So I'm going to subtract 24x from both sides. And I'm going to subtract the 112 from both sides. So I have 16x to the second minus 24x minus 112 equals 0. Now, before you go nuts, you always think about the greatest common factor, because the greatest common factor, if you can take one out, makes the problem simpler. Right now, if you go straight to just parentheses, first times first is 16x squared. Well, that could be x times 16x, could be 2x times 8x, could be 4x times 4x. You have three different ways that could happen. But if there's a greatest common factor, it decreases the number of choices. Technically, they're all even, so you could at least take out 2, but anything else. I could also take out an 8. You can take an 8 out of this. And 8 goes into 24. I can take an 8 out of that. Does 8 go into 112?
Yeah.
Yeah. 8 comes out of all of them. And again, you can just check on the calculator. 112 divided by 8. Yeah, 8 goes into there. So we're going to take an 8 out of each one. And remember, when you do that, you're dividing the 8 out. So it's 8 times, divide by 8, divide by 8, divide by 8. So that's 2x squared minus 3x minus 8 goes into this 14 times. But now we can set up the parentheses. It's 8 times parentheses. First times first, instead of being 16x squared with 3 different ways to make it happen, it's a 2x squared. So to make it 2x squared, the only way is x and 2x. It has to be an x and 2x to make that happen. Has to be. No other way. The last sign is negative. The last sign is a negative 14. So forget about the 14, forget about the 3x. It's a negative. The only way to make a negative last term, these two have to be positive and negative. Or maybe it's negative positive, but they have to be different signs. Last times last is a negative, so it has to be a positive times a negative. So since this is the factoring question, I promise to give you one that'll factor. So the only way this is going to work, it has to be x and a 2x. It has to be a positive and a negative. Then 14. Well, 14 is either going to be, and I always put the pieces of the puzzle on the side so I know what I have to work with. 14 is either 1 times 14 or 2 and 7. When it was 112, man, all the different ways to make 112. 1 and 112, 2 and a 56, 3 and 30. Not 34. I can't do that. Right. So what do you want to try? 1 and 14 and 2 and 7? 1 and 14? So if I'm going to try 1 and 14, I can't put the 14 in here with the 2 because 2 is even, 14 is even. If I put 14 with the 2, I should be able to take out another 2 because they're both even. If I can take a 2 out of this, I should have been able to take a 2 out of there from the very beginning. So putting the 14 in there is a waste of time. The only way the 1 and 14 would work, the 14 would have to be here, the 1 would have to be there. That's the only way the 1 and 14 would fit. I mean, you could try it, but it wouldn't work. You wouldn't make negative. Outside is negative x. Inside is positive 28x. 28x and negative 1x are not going to make negative 3. So it's not 1 and 14. So maybe it's 2 and 7. So the same thing about 2 and 7. You can't put 2 with this 2 because you should be able to take another 2 out. So the only way these two puzzle pieces will fit with what we have, it would have to be a 2 here and a 7 there. Outside, x times negative 7x. 2 times 2x, positive 4x. -7 plus 4, 4. -7 plus 4, -3. That's what we want. That's how it fits. So now we let each factor equal 0. Over there, we have this. We have 3x times x squared plus 16 equals 0. And we let the 3x plus a 0, and we let the x squared plus 16 equals 0. We let this one equal 0. Over here, we don't use the 8. What's the difference over there for the 3x versus this one? Doesn't have an x. This doesn't have an x. We're only solving for what is x equal. Over here, there's no x. I mean, basically, you go 8 equals 0 because there's no x there. And 8 does not equal 0. So if it's just a constant, you don't worry about it. You're only solving for the factors that have x's. So this x plus 2, you might be 0, or 2x minus 7. Maybe you're the 0. Subtract 2. This x is -2. Add 7. 2x equals 7. Divide by 2. This x is 7 over 2. So -2 and a 7 over 2. Okay. So let's go on back to 10 and we will keep on reviewing.
Just for reading purposes, 2.3, correct?
No, all the solving is 2425.
2425, okay.
2.3 on the review sheet is questions 1, 2, 3, 4.
Okay.
The simplifying the radicals.